Welcome to MOVITRAC LTE-B Plus Basic and Intermediate Training. This is session 9. This is our second to last session. We're going to spend this session and the next talking about a topic that is borderline advanced, and that is Fieldbus communications with the MOVITRAC LTE-B Plus. You may be surprised to know that essentially an entry-level VFD has Fieldbus capabilities, but as I told you in the beginning, the MOVITRAC LTE-B Plus is actually a very powerful VFD for its price point. Fieldbus communications allows you to add a degree of automation not possible with many entry-level VFDs, so we're going to see some exciting things you can do with it. So let's dive in and start talking about Fieldbuses. We're going to begin by talking about how to get your MOVITRAC LTE-B Plus or MOVITRAC LTE-B set up on a Fieldbus, and then in our next session we'll get into the software side of things. First of all, let's just review. The MOVITRAC LTE-B Plus has built-in Fieldbus communications through its communications port on the front. The communications port supports several what are called classic Fieldbus standards. Now, what do I mean by this? Well, I mean Fieldbuses like this: S-Bus, Modbus RTU, and CAN Open. These are Fieldbus standards that were developed in the late 1970s and the 1980s. They are older technologies that still have a very strong presence in industry because of legacy applications. They're relatively low speed, but they are very capable. The MOVITRAC LTE-B Plus supports these three standards just from its front communications port. I should mention that CAN Open is not available on the MOVITRAC LTE-B. It's a B Plus feature only. S-Bus is actually a CAN-based Fieldbus as well, but it runs a proprietary SEW Eurodrive protocol. So if you want to interface a PLC or other industrial controller to one of these Fieldbuses, your MOVITRAC has everything it needs to get connected. Now, what if you're saying, I really want a more modern Fieldbus standard, one of the Ethernet-based ones? Can I do that? The answer is yes, you can. There is a way to do this. You have to add an extra component. You have to add what's called an external gateway. This is something you can buy from SEW Eurodrive, and it opens up many additional Fieldbus standards. Now, a gateway is actually two parts. You order these two things together from SEW Eurodrive. You get what's called the UOH11B, that's the orange enclosure, and then you order a specific Fieldbus card that fits in it, and that implements the Fieldbus standard you want. Now, these are the Fieldbus standards available through cards, Ethernet IP, Modbus TCP, EtherCAT, Profinet, and there are also two additional legacy Fieldbus standards, Profibus and DeviceNet. So this will allow you to connect other Fieldbus standards up to your MOVITRAC LTE-B or B+. Okay, let's talk about how you get everything connected. Now let's say you're going to put together just a standard classic Fieldbus, so you're going to do Modbus RTU or S-Bus or CAN Open. You don't need a whole lot. You just need to buy cable set A or B. You'll need one for each VFD. Now here's how it works. You connect the splitter device to the front of each VFD, and then you chain the VFDs together with RJ45 cables. These are the same kind of cable that you use to connect your PC to an Ethernet port in your office, for example. So you chain them together with RJ45 cables, and you have a terminating resistor at the very end of the chain. Never forget that resistor, by the way. It's very important. If you forget it, the VFDs either won't communicate at all or they will communicate very unreliably. So that's crucial. And then, of course, at the other end of the chain, you have a PLC or other industrial controller, which should also have termination in it. Now, if you use this setup, you can have either a maximum of 32 or 63 VFDs on your Fieldbus. 32 is the limitation of Modbus RTU. S-Bus and CAN Open can go up to 63, so that's a classic Fieldbus. Incidentally, maybe you remember this from an early session, if you have a MOVITRAC LTE-B Plus IP66 version, you do not need the splitter because it has two built-in communications ports, so it has a built-in splitter. So all you need is a terminating resistor for the last VFD and some RJ45 cables to get them connected. It's pretty easy to build a classic Fieldbus. Let me show you a variation on the classic Fieldbus theme. You can also do this if you have the engineering adapter. Remember, that's called cable set C. You can replace the last splitter with cable set C, and this allows you to engineer all the drives as well. So you notice this is basically the same setup, except at the very end you have cable set C, and then you can plug a PC in using the USM21A or USB 11A USB adapter. So this setup really gives you maximum flexibility. You have a Fieldbus that your PLC or controller can communicate over, but when necessary, you can plug in a PC through that USB adapter and engineer all the VFDs as well. Cable set C contains an internal terminator, so it has to be the last one on the network. Notice there it's at the end, and when you disconnect the PC from it, it just acts as a splitter with a built-in terminator. All right, so that's your basic way of creating a classic Fieldbus. Now, what if you want to use the gateway to connect a more modern Fieldbus, like an Ethernet-based one, say Ethernet IP, for example? How do you wire that up? Well, you do it almost the same way. Here's what you do. You create a local S-bus Fieldbus using splitters and the terminating resistor, and then you connect the external gateway to that, and it links the second Fieldbus, maybe your Ethernet-based one, to the local S-bus Fieldbus. So you can see a very similar setup, but notice that your PLC or your controller is talking to the main Fieldbus, which talks to the gateway, and then the gateway talks to the individual VFDs. By the way, when you use a gateway, you have a limitation of 8 VFDs maximum on the S-bus. That's not a limitation of the S-bus, it's a limitation of the gateway. It can only manage 8 VFDs. The way you would set this up is you would have the gateway at one end and you would have the terminator at the other end and the VFDs in between. This is how you would set things up, so it's relatively simple and straightforward. Now let's talk about how to wire up the gateway if you're using one. These are diagrams from the MOVITRAC LTE-B Plus manual. It's very simple. Now what you'll need is an RJ45 cable with simply wires at one end. You get this with cable set A, but you can just take an ordinary network cable and cut off the connector at one end and strip the wires. Now this diagram on the right shows the communications port on the MOVITRAC LTE-B Plus. You're going to make a connection to just 3 of the positions here. You're going to use 1, 2, and 3. That's S-bus minus, S-bus plus, and a ground connection. And you're going to wire these to X26, 1, 2, and 3 on the gateway. And you can see right there, the color code on a standard Ethernet cable is orange, orange-white, and green-white. So you simply make those connections to terminals 1, 2, and 3. That connects your first MOVITRAC LTE-B Plus to your gateway, and that's the beginning of your S-bus. Notice there are 2 additional connections, and that's because you have to provide power to the gateway. It requires 24 volts. So what you'll need to do is connect an external 24-volt power supply to X26.6 and X26.7. You can see those right there. By the way, don't try to grab power from connection 6 on the RJ45 connector. There is not enough current there to power the gateway. That should not be used as a power supply. You must use an external supply to power your gateway. All right, and that is all you have to do to get things wired. It is pretty simple. Now, we need to set a few parameters to get everything working right. So the first thing you do is go to parameter 12 and the basic parameters, and you need to select the VFD control mode. These are the control modes that support Fieldbus communication, modes 3 through 8. Notice there are 2 for each Fieldbus type. The first 2 handle S-bus, the second 2 Modbus, and the last 2 CAN open. Why are there 2? Well, it's very simple because there are 2 ways of handling the ramp when you're in Fieldbus control mode. One uses the internal ramp parameters, and the other allows you to send the ramp value over the Fieldbus. So you pick the one you wish to use. And by the way, these last 2 are only available on the MOVITRAC LTE-B Plus. They are not available on the regular B. If you're going to use a gateway, the ones you want to pick are 3 or 4. You want to pick S-bus. And you pick either the one that uses the parameters for the ramps or the one that allows you to send the ramps over the Fieldbus. It's your call. So that's the first parameter you have to set. Then you move on to parameter 15. This is where you pick the terminal control variant. Remember, in an earlier session, I talked about how when you're in keypad control mode, you have a kind of limited terminal control mode available on that front I/O connector. Well, that is also true when you're in Fieldbus control mode. There are a number of terminal control variants with limited functionality. I'm going to talk about just one of them right now, and we'll talk about some of the others in our next session. But you might want to set this, for example, to variant 0, which is a very convenient one and an appropriate one for Fieldbus control. Actually, variants 0, 2, 4, 8, 9, 10, 11, and 12 are all identical. Only digital input 1 does anything. It's a run and a stop signal. So basically, it's an enable, disable signal. You could either just jump it to a 24-volt pin, and that would permanently enable the VFD, or you could connect it up to a switch if you wish. Notice that digital inputs 2, 3, and 4 don't do anything. They have no function. So these 8 variants all work the same way. All right, moving on. The next parameter, we need to set the Fieldbus address, and this is set through parameter 36. Parameter 36 is an interesting parameter. It actually has 3 separate sections to it, so there are 3 different things you set with it. The first is the Fieldbus address. So when you go in to set this up, it will say ADR and give you a number. This will be a number from 1 to 63, and you need to set it to an appropriate address. By the way, this is the same as the VFD's engineering address. Several sessions ago, I talked about how you could engineer a network of VFDs that were connected together, and you had to set each one to a unique address. Well, as it happens, the Fieldbus address and the engineering address are the same, so you're setting it in the same way and in the same place. Let me give you a few rules for setting addresses. These are very important that you observe these if you wish everything to work correctly. First of all, every VFD must have a unique address. If you have duplicate addresses where 2 or more VFDs have the same address, you're going to have problems, so don't do it. Secondly, the addresses can be in any order. They do not have to be in the order the VFDs are connected to the Fieldbus. As long as every number is different, everything is fine. They don't have to be sequential. You don't have to do 1, 2, 3, 4, etc. You could have a random group of numbers as long as they're all unique. In general, it is smarter to have sequential numbers just because it's easier to keep things organized that way, but there is no rule saying you have to. And then finally, this is an interesting point. It's better to set the address with the keypad on the VFD than LT shell. And here's the reason. If you go into LT shell and you change the address, as soon as you do it, LT shell will lose connection with the VFD because you changed the address, and you'll have to scan back into the network to work with it. It's generally smarter just to set these parameters from the front keypad, so that's my recommendation. Do it that way. Now, I need to pause before we look at any more parameters to talk about how you set up addresses when you're using the external gateway. This can be a little confusing at first, so let me clarify things. The VFD's Fieldbus and the engineering address only applies to the local S-bus in the engineering network. When you connect up the gateway, which connects you to another Fieldbus, like an Ethernet-based one, that has its own independent addressing scheme. The addresses you set on the VFD have nothing whatsoever to do with the addresses that are visible on the main Fieldbus. Let me illustrate it this way. Let's say we have our gateway set up here. We've got our S-bus on one side, and we have an Ethernet IP Fieldbus on the other side. Maybe we've picked these addresses for our VFDs, so we have 3, 12, 7, and 19. You notice they're in no particular order, but every one is unique. All right, the gateway will be perfectly happy with that. It will find those 4 VFDs, and it will be able to communicate with them. But on the other side, on the Ethernet IP Fieldbus, we have a totally different addressing scheme. The gateway will have an IP address, and the PLC will have one. Maybe the gateway has the address 192.168.10.4, and the PLC has the address 192.168.10.105. That's perfectly fine. When the PLC talks to the gateway, it will talk to it using IP addresses. When the gateway talks to the VFDs, it will use S-bus addresses, and everything will work. I'll explain this in a little more detail before we get to the end of this session. Okay, back to parameters. Another thing you have to set, and this is the second parameter in parameter 36, is the Fieldbus baud rate. That is the speed at which the S-bus or Modbus communicates. This is important because everything has to be communicating at the same speed. So if you set up a classic Fieldbus with a PLC, you'll need to be sure it's on the same baud rate that you set here. And if you're setting up a gateway, then you'll have to pick a gateway appropriate baud rate. So you set this in parameter 36, and these are your choices that are available to you. You can see you have a number of different speeds, so pick whichever one is appropriate. If you're using a gateway, pick choice 1, which is 500 kilobits per second. That is what the gateway wants to see by default, so use that one. And here's another point that I will make. The baud rate affects the maximum cable length your Fieldbus can be. So if you go to a really high speed like option 5, 1 megabit per second, you're going to be restricted to a shorter maximum cable length. On the other hand, if you go to a lower speed like choice 2, 125 kilobits, you can have a much longer Fieldbus, but your communications is slower. I recommend you look in the MOVITRAC LTE-B or B+ manual because it gives you a table of maximum cable lengths for the different speeds, and I recommend you definitely pay attention to those. All right, we come now to the third parameter in parameter 36, and that has to do with communications fault handling. It is possible, and frequently does happen with Fieldbuses, where communication drops. And the VFD needs to know, what do I do if I lose communication with my controller? Do I just keep running or do I immediately fault? Well, you can pick that behavior. Setting the third parameter in parameter 36, it determines how the VFD handles a communications failure. So these are your choices here with this parameter. You can pick option 0, which is the default. It means just ignore it. If you lose communications, just keep doing what you're doing and hope it comes back. But if that's not acceptable for safety or other reasons, you can tell it to trip the VFD and shut down. What options 1 through 8 do is they have different amounts of time they wait before they trip. If you want it to wait a long time, pick option 8. It will wait 3,000 milliseconds and hope communications comes back in that time. If it does, it will not trip, but if it takes longer than that, it will. On the other hand, if you want it to trip almost immediately, pick option 1, 30 milliseconds, and within 30 milliseconds of losing communications, it will trip. Okay, so that's your third parameter and the last one that you have to set. Now, let's talk about using the gateway. If you're using a gateway, you're going to have to set the Fieldbus address. Now, this varies with each Fieldbus card because we sell a lot of different cards for different Fieldbus standards. So I'm not going to talk about all of them. We'd be here all day if we had to do that. So I recommend you consult the appropriate manual for assistance to learn how to set the address on the Fieldbus card in the gateway. Incidentally, I've put links in the video description below to our more common Fieldbus cards so you can download the PDFs and learn the specific details of each one. All right, what I'm going to do is give you an example that applies to 3 of our Fieldbus cards, the one that supports Ethernet IP, the one that supports Modbus TCP, and the Profinet card. All these work in the same way. They all have an IP address, and they have a switch on them that resets the card's IP address to 192.168.10.4. That is actually the SEW Eurodrive default address. Now here's the switch. It is the def IP switch, and here's how you use it. You first of all turn off the power to the gateway. You turn the default IP address switch on. You power up the gateway. You let it boot up. Then you shut it off again. You turn off the default IP switch, and then you're reset back to that default. And I'll just mention this again here. This is handy to know. With almost all SEW products that have an IP address, 192.168.10.4 is the default address. So you can always kind of count on that one being the default if you have a product that's brand new or one that you have reset. Okay, now, once you've got the address set, then you need to have the gateway learn the local S-bus to find out what VFDs are out there. So this is kind of step 2, learning the network. And in order to function as a gateway, all Fieldbus cards have to enter an automatic setup mode where they scan the S-bus to figure out what's out there. This is really easy to do. You use the second switch for that, the AS switch. So here's the steps that you need to follow. You power down the gateway. You connect and power up all the VFDs that will be on the S-bus. You turn the AS switch off. You power up the gateway. Then you flip the AS switch on and wait. And what you'll notice is that H1 light right below it's going to flash. What that means is the gateway is scanning the S-bus looking for VFDs, and it may take a few seconds if you have 8 of them, but eventually it will go out, and at that point you're all set, the gateway is configured, just leave that AS switch on. It should be on at all times, and the gateway will perform normal operations from that point forward. Now, if you ever change the S-bus, either by adding or removing a VFD or changing its address, you must go through this process again. You must turn the AS switch off and on so it can relearn what's out there. If you don't do that, you will either get a fault on the gateway or it just won't work correctly. So do remember that. I think it's time for a demonstration. Let me show you how to set up a gateway. I've got a gateway here with an Ethernet IP card in it. I'll connect it to my demo unit and just show you how it works, and then we'll be done with this session. All right, we're going to configure our gateway. The first thing we're going to do is reset the IP address to the default, so I'm going to turn the def IP switch on. Notice I'm using a screwdriver and not a pencil to do this. I power up my gateway, and I wait for it to boot. The way you know it's done is the lights will stabilize and stop changing. Takes a few seconds. It's resetting the IP address here. And now it's done, so I'm going to power it off, and then I'm going to turn the def IP switch off since we're done resetting it. And we'll power the gateway up again. Wait for it to start. You'll notice the H1 light at the bottom comes on permanently. That means the gateway's unhappy because it's not configured. We will fix that, of course, by turning the AS switch on so the gateway can discover what's out there and go into gateway mode. So I turn the AS switch on. Notice the H1 light is flashing multiple times. Once it stops flashing, the gateway is done. It's auto-configured, it's ready to go. Now, before we wrap up, we need to just confirm that our gateway is communicating on the default IP address that we've reset it to. So what I'm going to do is plug a cable between my PC's Ethernet port and the gateway's Ethernet port. And then I'm going to go into the command prompt in Windows and I'm going to issue a ping command just to see if the gateway responds. I type in ping 192.168.10.4. And we can see, yes, the gateway is responding, so that means it is working on the default IP address like we expect. So it's good to go. All right, well, that is the end of session 9, so hopefully that made sense. And we're all ready now to move into our last session. We'll look at the software side of Fieldbus communications, and then we will wrap up our course. See you next time.